Welcome back, Crammers, to question 1. A train travels along a straight horizontal track between two stations A and B. The train starts from rest at station A and accelerates uniformly for t seconds until it reaches a speed of 20 meters per second. The train then travels a constant speed of 20 meters per second for 3 minutes before deaccelerating uniformly until it comes to rest at station B. The magnitude of acceleration of the train is twice the magnitude of the deacceleration. On the axis below, sketch a speed time graph to illustrate the motion of the train as it moves from station A to station B. So, in the first part, we can see that it starts from rest and accelerates uniformly. So we can draw a straight line here. It goes on for t seconds, and it reaches 20 meters per second. So we just write here 20. In the second part, the train then travels a constant speed for 3 minutes. Now, since the unit here is seconds, we convert 3 minutes to seconds, so this is 180. And since t is already here, we have to add it. So we add t. Before accelerating uniformly until it comes to rest at station B. The third part then states the magnitude of the acceleration is twice the magnitude of the deacceleration. That means the acceleration is less steep than the deacceleration. So we can write here that it is more steep. And since we simply have to combine twice the magnitude of the deacceleration, we have 180 plus t plus, see here we have t as the acceleration, so it's plus 2t. So that means it just comes to rest at 180 plus 3t. Stations A and B are 4.8 kilometers apart. Find the value of t. Now we can see that the graph makes 3 distinct shapes. We have a triangle, a square, and another triangle. If we can find the area underneath the graph, we know that that area is the distance. And since our speed is given as meters per second, we convert kilometers to meters for simplicity. So here we have 4,800 is equal to, so the area of the triangle is 20 times t divided by 2. 20t divided by 2. This cancels out. And we have 10 here. Then the second part, we have 20 times 180 plus t minus t. So this cancels out. We have 180 times 20. And we have, for the next value, it is 180 plus 3t minus 180 plus t. So this cancels out, this cancels out. 3t minus t is just 2t. And this is multiplied with 20. And since it's a triangle, we divide by 2. This cancels out. Now, we can simplify this to 4,800 is equal to 10t plus 180 times 20. So that's just 3,600 plus t plus 20. So that's 20t. If we bring this to the other side, we have 4,800 minus 3,600 is equal to 10t plus 20t. If we combine all the like terms, we have 1,200 is equal to 10t plus 20t, that's 30t. To isolate t, we divide by 30 on both sides, and t is equal to 40. Find the acceleration of the train during the first t seconds of its motion. So as seen before, if this is 20 and this is t, we know that 20 is equal to a times t. However, since we already found t in our last question to be t is equal to 40, we simply input this here. So 20 is equal to 40a. We divide both sides by 40 to find what a is, and a is equal to 1 over 2 meters per second squared. Thanks for watching. Cram, then scram.